Okay, start with chapter 4, which is the semiconductor diode. Okay, semiconductor diode. What do you know? By now you must know the symbol of the diode. Looks like that. Everybody must be able to draw this symbol of the diode, anode and the cathode. Anode and the cathode. What is a diode? You must know that a diode conducts only when it is being forward biased. It only conducts when it's forward biased, and when it's forward biased, it acts like a closed switch. Closed switch, so current will flow. Then you must know that this same diode, when this diode is a reverse bias, what then? Then it acts like an open switch, meaning no current. Obviously, it's open, no current will flow through. So, next thing you must know, diode has a characteristic curve, and that you must know for all these components. How does it look? Something that looks like this. There you go, and it looks just go like that, and there's the characteristic curve. What do you need to know? You must know that this region here is the forward bias region. This region here is when it's reverse bias. So reverse bias, forward bias. Points that you must look out for exactly. There will be something called a 0.3 and a 0.6. Now what is that 0.3 and 0.6? 0.3 will be for germanium and 0.6 for silicon. Or what am I talking about? Okay, threshold voltage. Threshold. That no, right? Threshold voltage. Threshold voltage. What about threshold voltage? Okay, threshold voltage. The voltage that you need to overcome the barrier potential. That is for a germanium diode, and for a silicon diode it will be 0.7 voltage. The voltage that you need to overcome the barrier potential, that is basically for current to flow. Threshold voltage. So that's the voltage needed to overcome the barrier potential. To overcome the barrier potential. Okay, and that basically means basically means for the current to start flow, and diode to work, the diode to operate. Alright, so that stuff you know from N1, I assume. Yes, everybody must know that from N1. Let us not waste so much time on that. Anyway, characteristic of a diode. That's how it looks. You must be able to draw it. Please labels. This will be voltage. This will be current. Reverse bias region, forward bias region, 0.3 volts, 0.6 volts. Can also indicate here that this is breakdown, reverse, breakdown voltage. Yep, and then please Symbol of a diode. You must know that it acts as a closed switch when it's been forward biased, and it acts as an open switch when it's reverse biased. This is a revision, please. Okay, then you need to know the following. Going on to the next topic would be rectification. Okay, what is a rectification? Well, the textbook gives a complicated explanation. A rectification is the process of converting an alternating voltage to a unidirectional voltage. Well, simple. You have AC voltage. Rectify AC voltage. You want to get a simple DC voltage. And that's basically what rectification is. You can only achieve this through the process of rectification. And you should know by now, normally if you rectify, it's same like your cell phone charger. You have AC, 220 volts AC. Then after that you have, what do you call this? Your transformer, which does what to this AC wave? It will step it down, and then after the step down is taking place, what then do you get after you step it down? Then you have your rectifier circuit. Now what we will be looking at now, the rectifier circuit will be basically a full wave rectifier. And what does it do? It changes that wave into something like this. Ultimately, with the use of a capacitor, it will filter that circuit out until it's a real smooth output, which look basically like that at the end of the day. Obviously after you filter it quite a lot. Okay, so that's rectification. Taking your AC waveform, changing it into a DC waveform. In a nutshell, basically. What must you know? You must know the following. And the following will start with, again, this is revision of N1. You did the stuff in N1. This is just basically revising your N1 work. Let's see if you can still remember. Okay, so first, if you start off, you are familiar with half wave rectifier. What is a half wave rectifier? Okay, half wave rectifier is what? Circuit. It consists out of what? You have your transformer, and then you have one diode, and then you have one resistor, which is referred to as RL, which is your load resistor. So you must be able to explain what happens in the circuit. Well, you know, half wave rectifier, give you an input. If you have an input AC wave, what happens? Your output will look like only something that look like this, and that's your output. This part is gone. Why is it gone? Because if you look at the circuit, there is a positive and a negative cycle. Positive cycle, negative, positive, negative, positive, and your negative cycle. So if you look at the positive cycle, current flows from the positive side, flows through this diode, which is now forward bias. Because it is forward bias through the load resistor, and you will get your output because current is flowing. Then you go to the negative cycle. Start with the negative cycle. current flows through the negative cycle, start on this side, goes up there, come here. Now this diode will be reverse bias. Because it's reverse bias, it acts this region here, close switch, close switch. So close switch, no current will flow through the close switch, and that's what you will have. Then again, positive cycle, open switch, sorry, close, open switch. No current will flow. Then positive cycle, close switch, current flow, reverse, negative cycle, open switch. That's your output. Okay. Now this drawing input and output. Now it's expected of you to draw input and output waveforms in line, meaning if this is your input, we want to see your output looks. Please use a ruler. I do not have time now for a ruler. Please just use a ruler like that. Nothing like that, nothing like that. That will be your output, that will be your input. Half wave rectifier. Then we go on to full wave rectifier. Now what's the purpose of a full wave rectifier? Full wave rectifier make use of two diodes. In the book it will be referred to the full wave center tap. The full wave center tap, it looks like that. There's the full, it's a transformer, one resistor and another resistor. Okay, and then load resistor, center tap, so it goes there, and that's what's called right there. Okay, then they have there's a B and a C. Okay, a resistor. In this case, you have, if you look at your input, again, input will be an AC waveform. In this case, your output will look like this. It will conduct for every single cycle. What do I mean? For the positive and the negative. How does that happen? If you look at this positive cycle, you will see current will be flowing through diode 1. Diode 1 is forward bias, current flows through that, and it goes right down into tap, and there it goes. Negative cycle, you will see diode 2 is also forward bias, flow right through, go around there, so the load resistor back there. Okay, so in both cases, positive and negative cycle, the diodes will conduct. That is why you will have, for the positive cycle, you will have an output. Negative cycle, you also will have an output. Then again, positive cycle output, negative cycle output, and there you have it. Okay, then there's another circuit after this, the one that follows this one, and the circuit will be your, what is it now, a popular full wave bridge rectifier. These, you need to be able to draw all these circuits yourself, as well as label it and draw it extremely neatly, like I did.
Please draw with pencil and label your drawings because it's expected of you to draw it, please. Okay, then how does the circle look? Well, again another boring transformer there. Then, well, you can refer to the drawing on page 74. In this case, you'll have, here's a point, one diode there, okay, another diode there, and you will see that these two diodes, opposites, they will conduct at the same time, and then these two will also conduct at the same time. Okay, that will go there, and then this must go to the load resistor. RL. I'll label this as number 4, number 2, number 1, and number 3. Okay, how does this look? Input wave will look like this. My output wave in this case will look similar to the previous one, and it will look now exactly like this. So how does it work? You will see there in the book, you look on page, current will start to flow, positive and negative. Okay, so current start to flow, there it goes, and then it comes up, and at this point it cannot go through number 4, it will have to go through number 1, because number 1 will be forward bias. Okay, it flows through there, it won't go through 2, it will go in there, right through the load resistor, come down here, and come up, and then this point it will go through diode 3 because it's forward bias, come down here and back to my negative. And that's how your current will flow for the positive cycle. For the negative cycle, start on this side, current flow, flow, flow. Where does it go? Comes up through diode 2, through diode 2, can't go through that diode 1, so it will go through the load resistor, come back here, up, then go through diode 4 and up and go back to it. And that is flow of current. You can see it on page 74. If you have any problems, you need to know for every cycle, positive, negative, positive, negative, positive, negative. 2 diodes conduct at the same time. So for the first positive cycle, which was the red, it was diode 1 and diode 3. Negative cycle, it was diode 2 and diode 4. Then again 1, 3, 2 and 4, 1, 3. So for each cycle, 2 diodes will be forward biased at the same time. 2 diodes was forward biased, diode 1, diode 3 was forward biased, diode 2 and 4 were reverse biased. Negative cycle, we have diode 2 and 4 forward bias, 1 and 3 reverse bias. Input, output. Okay. Then there is the smoothing capacitor, which is on page 75. Well, you can read through it, you can read through it. The purpose of a smoothing capacitor basically is to get rid of this part here. Remember, you set with this as on your output. You want to get rid of that part there. Smoothing capacitor will smooth it out, it charge and recharge, charge, recharge the whole time until until, if you look closely at this part here, until that part, so it starts like that. So here the capacitor charge, and in this period it will discharge, then it charge, goes up again, and then it discharges. But this time, this point here is a little bit higher. Then it charges again, and it discharges, and again this point is higher. So this point, if you look at this point here, that point, it actually increases the whole time until your charge and discharge reach that same point. That will be the ultimate goal. Achieve that, means your output will look basically a straight line. You can read more about that on page 75. Homework. Okay. Then let's stop quickly for this part.